Good afternoon, or morning, or evening, or whenever you're watching this. This one is going to be on a weak acid practice problem. So back to our notes. There's four of them, and I'm going to work through each one of them on an individual video. So let's start with this one. What is the proton concentration and the pH for the ionization of 0.2 molar acetic acid? And notice I give you right here the Ka, but normally you would look that up yourself. And can successive approximations be used? And can the ionization of water be ignored? All right, step number one. If you'll notice, I did not put the equation above it. So acetic acid, we're going to say HAC goes to a proton plus acetate, and the Ka is the proton acetate all over HAC, and that is 1.8 times 10 to the minus fifth. All right, do we know what we started with? And the answer is yes, 0.200 molar. Did we start with any of the protons or acetate? No. Minus x, x, x. All right, so 0.2 minus x, x, and x. All right, so that's all the information that I know. I need to plug it into my equation. So 1.8 times 10 to the minus fifth is equal to x squared over 0.200 minus x. I'm going to use my approximation, so I'm going to get rid of that. And x squared is going to be 1.8 times 10 to the minus fifth times 0.2, and I'm going to square root that to find x. All right, 1.8 to the negative fifth and 0.2 and square root. 1.89, and we get 2 sig figs, so 1.9 times 10 to the third. All right, the answer is 1.9 times 10 to the minus third, but can I use it? I need to check. So I'm going to divide it by my original concentration and multiply it by 100. And I get 0.94%. Let me do a double check. Yes, a 0.95%. So that was a very good assumption. And it is greater than a minus 6, so I can ignore water. So I have now checked to make sure that my assumption was valid and that I can ignore the presence of water. And now what am I going to do with that? X can now be plugged in into my table. All right, so 1.9 times 10 to the minus 3 molar for those two. And 0.2 minus that isn't even going to change. In fact, it's 0.198, and that rounds back up to 0.2. You know what? I better write it down, though. And I get to keep that many. Okay. There's my three equilibrium concentrations, and now I want to know what the proton concentration is and the pH. So my proton concentration is the 1.9 times 10 to the minus 3 molarity, and my pH is a negative log of that. and turns out to be 2.72. All right, that is an acidic pH, but I started out with an acid, so I expected that. All right, there is weak acid problem number one. What was interesting about this? All right, not too much, except I used point 0.2 instead of point 0.1, so I hope you noticed that the X got even smaller compared to all of the previous examples that I've been doing. And I filled out the complete table, but the problem really did only ask for the proton concentration and the pH, but I'm going to keep filling out the entire table for a while just so that you can see every problem can be done that way. All right, until next time, Jolly out.